Hello everybody, welcome into another lesson. So today we are going to talk about matrix addition, subtraction, and scalar multiplication. Now we're saying scalar multiplication, we're not doing matrix multiplication today. That'll be the topic of the next lesson. That's a whole different thing than scalar multiplication of a matrix. So addition and subtraction of matrices, that only works if they are both the same dimensions. If they are different dimensions, you can't add or subtract them, so right away you can't do anything with them. But addition of matrices is also commutative, and it's commutative and associative like normal addition. And then you have, if you take the zero matrix, here's a 3 by 3 zero matrix, so assuming that A is a 3 by 3, if I add the zero matrix to it, I'll get the matrix A back. Just like you add 0 to a number, you get the same number back. So those are your basic properties of matrix addition. And then you have scalar multiplication. That's going to be, for example, I have this 3 by 3 matrix. I have some constant C I want to multiply the matrix by. Well, that C would just distribute into every single term of the matrix. It would multiply by every single term in the matrix. That's all that would do. You just distribute that. You multiply it. So distributive is both commutative and associative. Distributive. Scalar multiplication of matrices is both commutative and associative. And you can also distribute it too. If I'm taking that same constant times the sum of both matrices, it equals the constant times one matrix plus the constant times the other matrix. So, and the idea is also, let's say that constant I'm multiplying by is -1. If I'm taking -1 times matrix B, that would be this. If I were to do A plus that -1 times B, that's going to be the same as A minus B. So matrix subtraction is not commutative or associative, just like regular subtraction isn't. But let's get into some examples here. Alright, so let's say I have a matrix A. This is going to be a 2 by 2 matrix. 1, -1, 2, -1. And then I have some matrix B with entries 2, -1, -1, and 8. Well, are they the same dimension? They definitely are. They're both a 2 by 2 matrix. We can definitely add them. So if I want to take A plus B, I'm just going to take both of these matrices, the 1 minus 1 to -1, plus I will take that 2, -1, -1, 8, and then I'm going to just simply add each entry with its respective position. So I'll end up adding 1 plus that 2, I'll get 3. I'll add -1 plus -1, I'll get -2. 2 plus -1 gives me 1. -1 plus 8 gives me 7. So there's my answer for A plus B. They're the same dimensions, and you should also get a matrix of the same dimension back whenever you add matrices. Now, what if we were to change this? This time, we're deciding we want to subtract B from A. I'm going to take matrix A minus matrix B. Well, we're going to still write out our matrices. You'll have 1, -1, 2, -1 minus that matrix of 2, -1, -1, 8. And matrix subtraction works the same. They both have to be the same dimensions. So all I have to do now is take each respective entry, subtract the numbers from the other matrix in it. So if I take that 1 minus 2, I'll get -1. I take -1 minus -1, well, that's -1 plus 1, that turns into 0. 2 minus -1 turns into 2 plus 1, that's 3. -1 minus 8 is -9. So my answer for A minus B would end up being -1, 0, 3, -9. All right. Now, let's throw you a curveball. What if I wanted to do 3A minus 2B? They're asking you for 3 times matrix A minus 2 times matrix B. How are we going to approach that? So, I'm going to definitely suggest we do the scalar multiplication for each matrix separately first. Let's take 3A. 3 times A, that's going to equal 3 times my 1, -1, 2, -1, right? Okay. All I have to do for scalar multiplication, that constant is called a scalar. I'm just going to distribute that 3 into each of the entries of the matrix. So this would turn into 3, -3, 6, -3. So there's my 3 times A. And then this is really 3A plus -2B. So let's say I take -2 times B. Well, that'll be -2 times my B matrix, which is 2, -1, -1, 8. Which I'll just distribute that -2. That's going to end up giving me -4, 2, 2, -16. So I found both pieces of this matrix expression. Now I just simply need to add them together. So I can now take that 3, -3, 6, -3, plus, because that 3A minus 2B is really 3A plus -2B, so we just add these together. This will be plus -4, 2, 2, -16. Now just simple addition, so 3 minus 4 is -1, and then -3 plus 2 is going to also be -1. 6 plus 2 is 8. -3 minus 16 is -19. So the result should end up being -1, -1, 8, and -19. So that wasn't too bad. That was a 2 by 2 example. Let's do a 3 by 3. So that was for a square matrix. This will also be a square matrix because we're going to do a couple 3 by 3s. So A will have entries, let's see here. Actually, this is going to be a 2 by 3, excuse me. No, a 3 by 2. If I could speak today. We're going to do a 3 by 2 matrix. Excuse me. Correct what I said earlier. This will be 8, -1, 2, -3. or actually 2, positive 3, and then negative 4, 5. And then you have some matrix B with the same dimensions. You have 1, 6, negative 1, negative 5, 1, 10. Alright, well, both of these are 3 by 2 matrices, 3 rows, 2 columns. They're the same dimensions. We can definitely add these. Let's just do a simple A plus B. So the good news is for matrix multiplication, matrix addition and subtraction, these don't have to be square matrices. As long as they have the same dimensions, you can add or subtract them. So A plus B, again, just take your members of A, add them to the members of B. So let's write this out. 8, negative 1, 2, 3, negative 4, 5, plus, we're going to have 1, 6, negative 1, negative 5, 1, and 10. So all we got to do is add the respective members and their positions, and we'll get the sum of these two matrices. So 8 plus 1 is 9, negative 1 plus 6 is 5, 2 plus negative 1 is 1, 3 minus 5 is negative 2, negative 4 plus 1 is negative 3, 5 plus 10 is 15. So the result should be another 3 by 2 matrix with entries 9, 5, 1, negative 2, negative 3, and 15. Now, of course, you know what we're about to do next. You know exactly what we're going to do. We're going to do A minus B. So we're just going to subtract the entries in matrix B from A. So 8 minus 1 is 7, negative 1 minus 6 is negative 7, 2 minus negative 1, so that's 2 plus 1, that'd be 3, 3 minus negative 5 turns into 3 plus 5, that's 8, negative 4 minus 1 is negative 5, 5 minus 10 is also negative 5. So that leaves A minus B having entries 7, negative 7, 3, 8, negative 4, negative 5, negative 5. Alright, now we got to do the big one. We're going to be asked to, once again, let's find 3A minus 2B. So it's probably best, once again, if we do the scalar multiplication for each of these two matrices separately and then come back and add them together. So let's look at 3A. That's just going to be taking 3 times all the entries in A. So 8, negative 1, 2, 3, negative 4, 5. So 3 times each of these entries is going to give you a matrix of 24, negative 3, 6, 18, negative 12, and 15. So there's your 3A matrix. Now the other part is negative 2B. So that's going to be negative 2 times the entries in B, which are 1, 6, negative 1, negative 5, 1, and 10. Okay. So multiply that negative 2 by each of your entries, you'll get a matrix of negative 2, negative 12, positive 2, positive 10, negative 2, and negative 20. So there's your entries for the negative 2B matrix. Now you're just going to add 3A plus negative 2B. So this will end up being 24, negative 3, 6, 18, negative 12, 15, plus that negative 2b matrix, which is negative 2, negative 12, 2, 10, negative 2, and negative 20. So all we got to do now is add these together. So 24 minus 2, that's going to end up being 22. And then negative 3 minus 12 is negative 15. 6 plus 2 is 8. 18 plus 10 is 28. Negative 12 minus 2 is negative 14. 15 minus 20 is negative 5. So the result of doing 3a minus 2b should be the matrix with entries 22, negative 15, 8, 28, negative 14, and negative 5. All right. That was a good 3 by 2 example. Let's do a really big one here. So that's going to be, we're going to do a couple 5 by 3 examples. Yes, I got to do some big examples too to really get it in. All right, let me get a different black marker. That might help. Let's see here. Matrix A, going to be some big matrices. We got negative 1, 4, and 0. 3, negative 2, and 2. 5, 4, negative 1. 0, 8, and negative 6. Negative 4, negative 1, and 0. There's your matrix A. We have a big 5 by 3 matrix. Matrix B should end up having the same dimensions. With entries, let's see, negative 3, 5, and 1. 2, negative 4, negative 7. 10, negative 9, negative 1. 3, 2, negative 4. And then we have 0, 1, and negative 2. All right, so both of these matrices have the same dimensions of 5 rows by 3 columns. These are both 5 by 3 matrices, so we can add them and subtract them. So, of course, let's do A plus B. So, instead of writing all these out, I think we can look well enough and add their respective entries. So, negative 1 plus negative 3, well, that's going to for sure give you negative 4. 4 plus 5 is going to give you 9. 0 plus 1 would give you 1. 3 plus 2, that's going to give you 5. Negative 2 minus 4 is negative 6. 2 minus 7 is negative 5. 5 plus 10 is 15. Let's go a little bit bigger here. 4 plus negative 9, or 4 minus 9, is negative 5. Negative 1 minus 1 is negative 2. 0 plus 3 is 3. 8 plus 2 is 10. Negative 6 minus 4 is negative 10. Negative 4 plus 0 is negative 4. Negative 1 plus 1 is 0. 0 minus 2 is negative 2. So your result should be yet another 5 by 3 matrix with entries negative 4, 9, 1, 5, negative 6, negative 5, 15, negative 5, negative 2, 3, 10, negative 10, negative 4, 0, and negative 2. And yes, it's true, we're about to do A minus B. You knew that was coming, right? Okay. So A minus B, we're just going to subtract the entries from B from those in A. So if I take negative 1 minus negative 3, that turns into negative 1 plus 3, which is positive 2. 4 minus 5 is negative 1. 0 minus 1 is also negative 1. 3 minus 2 is positive 1. Negative 2 minus negative 4 turns into negative 2 plus 4, which is going to be 2. 2 minus negative 7 turns into 2 plus 7, that's 9. 5 minus 10 is negative 5. 4 minus negative 9 turns into 4 plus 9, which is 13. Negative 1 minus negative 1 turns into negative 1 plus 1, which is 0. 0 minus 3 is negative 3. 8 minus 2 is 6. Negative 6 minus negative 4, so that's negative 6 plus 4, that's negative 2. Negative 4 minus 0, that's just negative 4. Negative 1 minus 1 is negative 2. 0 minus negative 2 turns into 0 plus 2, that's 2. So my result should be another 5 by 3 matrix with entries 2, negative 1, negative 1, 1, 2, 9, negative 5, 13, 0, negative 3, 6, negative 2, negative 4, negative 2, and 2. And then we got the big one to end them all. How about 3a minus 2b? If I want to do 3a minus 2b, so we got some scalar multiplication with these. Well, since we could still do a minus b originally, we can definitely do this with the scalar multiples. What I'm going to suggest is, though, of course, once again, we take 3 times matrix A. So, just to save board space, I'm not going to write out the original matrix. We're just going to take 3 times each of these entries in A. 3 times negative 1 should yield negative 3. 3 times 4 is 12. 3 times 0 is, of course, 0. 3 times 3 is 9. 3 times negative 2 is negative 6. 3 times 2 is positive 6. 3 times 5 is 15. 3 times 4 is 12. 3 times negative 1, that's negative 3. 3 times 0 is 0. 3 times 8, that's 24. 3 times negative 6 is negative 18. 3 times negative 4 is negative 12. 3 times negative 1 is negative 3. And 3 times 0 is 0. So there's my 3a matrix. Now I need to do my negative 2b matrix. So negative 2b, I'll just take that negative 2, multiply it by my b matrix. Alright, so negative 2 times negative 3, that's positive 6. Negative 2 times 5 is negative 10. Negative 2 times positive 1, that's negative 2. Negative 2 times 2 is negative 4. Negative 2 times negative 4, positive 8. Negative 2 times negative 7, positive 14. Negative 2 times 10 is negative 20. Negative 2 times negative 9 is positive 18. Negative 2 times negative 1, that's positive 2. Negative 2 times 3 is negative 6. Negative 2 times 2 is negative 4. Negative 2 times negative 4 is positive 8. Negative 2 times 0 is 0. Negative 2 times 1 is negative 2. Negative 2 times negative 2 is positive 4. Alright, So we got those matrices. Now all we got to do is take them and add them. So 3a minus 2b should yield a 5 by 3 matrix with the two of these added together. So negative 3 plus 6, well, that's going to be 3. 12 plus negative 10, 12 minus 10 is 2. 0 minus 2 is going to be negative 2. 9 minus 4, that's 5. Negative 6 plus 8 is 2. 6 plus 14 is 20. 15 minus 20 is negative 5. 12 plus 18 is going to be 30. Negative 3 plus 2 is negative 1. 0 minus 6 is negative 6. 24 minus 4 is 20. Negative 18 plus 8 is negative 10. Negative 12 plus 0 is negative 12. Negative 3 minus 2 is negative 5. 0 plus 4 is 4. So this would mean that 3a minus 2b equals 3, 2, negative 2, 5, 2, 20, negative 5, 30, negative 1, negative 6, 20, negative 10, negative 12, negative 5, and 4 would be my entries for 3a minus 2b. Alright, let's do a couple matrices with different dimensions. See what's going to happen. So we have matrix A. Let's see, it's got entries 6, 0, 3, negative 1, negative 4, 0. Then we have matrix B with entries 8, negative 1, 4, negative 3. Again, before you try to add or subtract anything, what you gotta do is figure out your dimensions. Matrix A has 2 rows but 3 columns, so this is a 2 by 3 matrix. Matrix B has 2 rows but 2 columns, so this is a 2 by 2 matrix. So we can't add or subtract, so A plus B equals no solution. Which also means the same for A minus B, because A minus B simply equals A plus negative of B, which would also be no solution. You can still take scalar multiples of each matrix. You could find 3A, and that would certainly give you 18, 0, 9, negative 3, negative 12, and 0. Scalar multiplication you can always do. If I take negative 2 times b, that's going to equal negative 16, 2, negative 8, 6. But I'm not going to be able to do 3a minus 2b because these are still different dimensions. So 3a minus 2b would also have no solution in this particular case. All right. So adding and subtracting and all that really proves that understanding how to determine the order of a matrix is absolutely critical. Now what if we have this one? A equals 3, 2, negative 1. B has entries of 4, 6, 2. We can clearly see they're not the same dimensions because matrix A has 3 rows and 1 column. This is a 3 by 1 matrix. Matrix B has 1 row but 3 columns. This is a 1 by 3 matrix. So we don't have a prayer of adding or subtracting. All we can do is scalar multiplication, but we cannot add or subtract these. They're different dimensions. So the bottom line is, if you're going to add or subtract matrices, they have to be the exact same dimensions. Now, you can also add multiple matrices together. Let's say we're given -5, 0, 3, -6, plus 7, 1, 2, -1, plus, actually it should be -2, -1, plus -10, -8, 14, and 6. If we look at all 3 of these matrices, they're the same dimensions. They're all 2 by 2, right? As long as all the matrices you're adding together have the same dimensions, you can add and subtract. So let's go ahead and do that here. So again, you're just going to add the respective entries in each of these matrices to come up with one matrix. So -5 plus 7 is what? That's 2. Minus 10 is going to be -8. Alright, 0 plus 1 is 1. Minus 8, that's -7. Alright, 3 minus 2 is 1. Plus 14 is 15. -6 minus 1 is -7. Plus 6 is -1. So when you add those 3 matrices together, you get -8, -7, 15, and -1. I got 3 more exercises, then we're done. Alright, let's see. 6, 9, -1, 0, 7, 1, plus 0, 5, -2, -1, 3, -6, plus -13, -7, 4, -1, -6, 0. So first thing we want to do is determine the dimensions. Each of these are a 3 by 2 matrix. You have 3 rows but 2 columns. So we can add all 3 of these together. So we'll just add their respective entries and come up with a single matrix. So 6 plus 0 is 6, minus 13 is -7. Alright, 9 plus 5 is 14, minus 7 is going to be 7. -1 minus 2 is -3, plus 4, that's +1. 0 minus 1 is -1, minus 1 is actually -2. 7 plus 3 is 10, minus 6 is 4. 1 minus 6 is -5, plus 0, that's -5. So adding all 3 of these matrices together should also yield a 3 by 2 matrix of -7, 7, 1, -2, 4, and -5. When you add or subtract matrices or multiply by scalars, it does not change the dimension of your matrices. Now the next lesson, when we get into matrix multiplication, that's not the case. That's why I want to do that as its own separate lesson. But two more problems here. So we're going to take 4 times the difference of these two matrices, -4, 0, 1, 0, 2, 3, minus 2, 1, -2, 3, -6, 0. Alright, so now you have 4, that quantity, times the difference of two matrices. So yes, we could distribute that 4 times each of the matrices and then take the difference, but I find it easier personally to still stick with the order of operations and stick with what's inside the parentheses and just do the subtraction. Both of these are 2 by 3 matrices, so we can definitely do the subtraction. So for now, what I would suggest is keep that 4 outside of your parentheses and then just come up with a single matrix. So -4 minus 2 would turn into -6. 0 minus 1 is -1. 1 minus -2 turns into 1 plus 2, that's 3. 0 minus 3 is -3. 2 minus -6 turns into 2 plus 6, which is 8. 3 minus 0 is 3. So now you're down to 4 times the matrix of -6, -1, 3, -3, 8, and 3. All we have to do is distribute that 4, and we found the result. So 4 times -6 is -24. 4 times -1, -4. 4 times 3 is 12. 4 times -3 is -12. 4 times 8 is 32. And then 4 times 3 is going to be 12. So that should be our final answer. Should be the 2 by 3 matrix of -24, -4, 12, -12, 32, and 12. I got just one more problem here. Alright, so we got half of a matrix here of 5, -2, 4, and 0, plus actually, I guess that's half of the whole quantity. Plus you got 14, 6, -18, and 9. Alright, so a very similar problem to the last one. You have half times the quantity of the sum of two matrices. Well, first, can we do the matrix addition? Well, these are both 1 by 4 matrices, so yes, we can add these matrices. I would personally, again, recommend you work inside your parentheses first, add these two matrices together into a single matrix, then distribute your 1/2. So we'll take 1/2 times our single matrix that we get from adding these together. 5 plus 4 is 19. -2 plus 6 is 4. 4 minus 18 is -14. And then we get 0 plus 9 is going to be 9. So now we just simply have half of a single matrix. All we have to do is the scalar multiplication, which should end up giving you 19 halves, 2, -7, and 9 halves. And yes, you can have fractions and decimals in a matrix. You will sometimes have that. So your final result should be a 1/4 matrix of 19 halves, 2, -7, and 9 halves. Alright, so that's it for this lesson. Next lesson we will actually do matrix multiplication. So I hope everyone has a great day. Take care.